Hello students, welcome back. Before going over to the next question, I'd like to request you to go through the playlist featuring the previous year's solved physics numerical board questions. I've shared the link of the playlist in the description box. Please do practice all of them before going to the exam. Let's draw the ray diagram for the image formation in a concave mirror when the object is placed at C. So this is the point where the rays meet after reflection. The image characteristics which we should be getting is that the image is real and inverted, it's of the same size as that of the object, and it's formed at C. But in this diagram, though we are getting a real and inverted image, yet the image is not of the same size as the object, and also it's not formed at C. Let's now understand where do things go wrong when we draw the ray diagram. It is the placement of the focus and the center of curvature. The distances that you need to take while drawing these points on the principal axis should be equal. To get a correct ray diagram for image formation, you need to take a very accurate measurement of these 2 points from the pole of the mirror, then your ray diagram will surely come out correctly. Let me show you how. First, draw a straight line marking the principal axis. Then, at one end of the principal axis, draw the concave mirror. Then mark the pole as P. Now get a scale and take any number on the scale and coincide it with the pole of the mirror. So here I have aligned the number 6 with the pole. Now we need to mark the point F and C, that is the focus and the center of curvature. Now take any number to the left of 6 and mark the focus there. If I choose 1 inch length to be my focus, so at the number 5, I mark my focus F. Now we know that our radius of curvature is twice the focal length. So if this is the focal length which is 1 inch, then exactly at another inch to the left, that is at the mark 4, I will have my center of curvature. So exactly at the number 4, mark the center of curvature. I have taken 1 inch to be the gap between the focus and the center of curvature. If you want, you can choose 2 units also. Like if you take 2 inches and mark focus here, then exactly after the next 2 inches to the left, you will have to mark your center of curvature. So your center of curvature would be at the number 2 now. So what length you have taken the focal length? Exactly double of that will be your center of curvature. So it's very important to keep this width, that is the radius of curvature, as double of that of this length, that is the focal length. So whatever you take this gap, exactly double of that if you take this gap and mark the center of curvature here, you will get the ray diagrams correctly. Now that we have marked the focus and center of curvature, let us draw the ray diagrams to verify whether our diagrams are coming accurate or not. Now let us place our object at center of curvature and find out where the image is being formed. I place my object here. AB is my object. Now one ray will go parallel to the principal axis. After reflection from the mirror, it will pass through the focus. Another ray will pass through the focus. It passes parallel to the principal axis. This is the point where the 2 rays meet. So this is the image A dash B dash. Now let's go and check whether our image characteristics are tallying with the characteristics which are given in the book or not. The first one is image is real and inverted. Yes, our image which we got is real and inverted. Secondly, it's formed at C. Yes, now we got our image formed exactly at C. Third, image size is same as that of object. Yes, indeed, we got the size of the image exactly same as the size of the object. So, our diagram is correct and the image characteristics are also satisfied. Now did you see? If you take the measurement of focal length and center of curvature accurately, then your ray diagrams are surely gonna come correctly. Let's try another one. So now we'll take 2 cases. One when the object is beyond the center of curvature and second when the object is in between the center of curvature and focus. And we'll find out the image characteristics and then tally with the image characteristics that are given in the book. So let's start. From the object AB, one ray goes parallel to the principal axis. After reflection, passes through the focus. Another ray passes through the focus, and after reflection, it passes parallel to the principal axis. Here is the point of intersection of the two reflected rays, and this is the point where the image is formed. So this one is A dash B dash. So now if we tally it with the image characteristics given in the book, the image is real and inverted. Yes, we got it. Image is formed between C and F. Yes, correct. Image is diminished in size. That also is satisfied. If we take the length of F and C correctly, we'll surely get the accurate ray diagram. Now come to the next case when the object is kept between center of curvature and focus. One ray goes parallel to the principal axis. After reflection, it passes through the focus. Another ray passes through the focus, and after reflection, it goes parallel to the principal axis. This is the point of intersection of the two reflected rays. And if this is the object AB, this is our image B dash A dash. Now let's tally it with the image characteristics that is given in your book. So image is real and inverted. Yes. It's formed beyond C. Yes. Our image is formed beyond C. That is to the left of C. It's magnified in size. Yes, our image which is formed is larger in size than the object. So if we take the measurement of F and C correctly, we will get the accurate ray diagram. Now children, here is one trick to remember the ray diagrams easily for the image formation in these two cases. Children are many times confused as to where the image will be formed if the object is to the left of center of curvature, and where the image will be formed if the object is to the right of center of curvature. So let me give you a trick to remember easily the image formation when the objects are placed in these 2 points. So now for the first one, that is when the object is beyond C or our object is to the left of C, left. Now where is our image formed? Our image is formed between C and F, which is to the right of C. This is right. Alright. So if the object is placed to the left of center of curvature, the image in that case will be formed to the right of the center of curvature. So this is the left-right rule. Now in the second case, when the object is placed between center of curvature and focus, you see here in this case, the object is placed to the right of the center of curvature, right of C. So if the object is placed to the right of C, you see here the image which is formed to the left of C. Alright. So they are interchanging their positions. That's if the object is to the left of C, the image will be right of C. The image will be diminished. And if the object is to the right of C, then the image will be formed to the left of the center of curvature and it will be a magnified image. Okay, so using this left-right rule, you can remember the ray diagrams for the image formations in these 2 cases. That is, for mirrors, we follow the left-right rule. Left-right rule. That is, if the object is to the left of the center of curvature, the image will be formed to the right of the center of curvature. And if the object is to the right of the center of curvature, the image which will be formed will be to the left of the center of curvature. So using this technique, you can easily remember where the image will be formed if the object is to the left of center of curvature and where it will be formed if the image is to the right of center of curvature. Now let's have a look at the image formation in case of convex lens. Now let's see the image formation in case of a convex lens when the object is placed beyond 2f1. So similarly, if we take the correct measurements and draw the ray diagrams, our diagrams would definitely come out correct. So let's start. Now let us draw the ray diagram for the image formation in a convex lens when the object is placed beyond 2f1. For that, just like the previous case as we did in mirror, we'll take a scale, we'll place it coinciding with the principal axis. Now let us choose any number and let that number coincide with the optical center of the convex lens. So here I have taken the number 4, which is coinciding with the optical center of the convex lens. Now let me choose f1 at a distance of 1 inch to the left of the number 4. So here is my f1. It is at a distance of 1 inch to the left of the number 4 or the optical center. Now if f1 is at 1 inch from the optical center, then exactly at 2 inches from the optical center will be my 2f1, right? So here I mark my 2f1. This is the optical center O. Now exactly to the right of O, the number 5, which is again at a distance of 1 inch from the number 4, I mark here my f2. Similarly, after a gap of 2 inches from the optical center to the right, that is the number 6, I mark my 2f2 over here. So now I have all the points equidistant from the optical center O. Now let us draw the ray diagram. We have our object AB placed beyond 2f1. Now one ray will go parallel to the principal axis. After refraction will pass through f2. Another ray will pass through the optical center undeviated. So we see that these two rays meet at this point, and here is the image which will be formed. So this is A dash and this is B dash. Now let's cross check with the one given in the book. Image is real and inverted, that's correct. Image is formed between f2 and 2f2, that's also correct. And image is diminished in size, that's also correct. Now let's have a look at another case where the object is kept to the right of 2f1, or the object is in between 2f1 and f1. Next have a look at the case when the object is situated between 2f1 and f1. Let's draw the ray diagram. One ray will go parallel to the principal axis. After refraction, it will pass through f2. Another ray will pass through the optical center undeviated. We see that the rays meet over here, and this is the position where the image is formed. So here is our image. So this is B dash and this is A dash. Now let's tally it with the one given in the book. The image is real and inverted is satisfied. It's formed beyond 2f2, that's also satisfied. And the image is magnified in size, that also is satisfied. Thus we see that in these two cases, the image formation is correct if we take the measurements accurately. So now let's have a look at the third case when the object is at 2f1. So one ray goes parallel to the principal axis. After refraction, it passes through f2. Another ray passes through the optical center undeviated. This is B dash A dash. Tallying it with the characteristics of the image that's given in the book. Image is real and inverted, that's satisfied. Formed at 2f2, that's also satisfied. And image is of the same size as the object also is satisfied. So thus students, you see, if you take the positions of f1 and 2f1 correctly, you will definitely get an accurate ray diagram. Now children sometimes find it difficult to remember the image characteristics when the object is kept to the left of 2f1 and when it is kept to the right of 2f1. So let me teach you a trick to remember this also. That is the left left right right rule. Now what is left left right right rule? It says that now if the object is kept to the left of 2f1, here this is to the left of 2f1, the image will be formed to the left of 2f2. This will be the left. Alright. Now I repeat, if the object is kept to the left of 2f1, the image will be formed to the left of 2f2. Second case, if the object is kept to the right of 2f1, this is the right. So if the object is kept to the right of 2f1, here you see the image which is formed is also to the right of 2f2. Alright. I repeat, if the object is to the right of 2f1, the image will be formed to the right of 2f2. So this is the left left right right rule. So this can be applied only for convex lens when the object is to the left of 2f1 and to the right of 2f1. Please don't get confused between the left right rule in case of a mirror to the left left right right rule in case of a convex lens. Now if we summarize the two rules for a concave mirror, if the object is to the left of C, the image is formed to the right of C. And if the object is to the right of C, the image formed is to the left of C, which is the left-right rule for a concave mirror. Now for convex lens, we have the left-left, right-right rule. It says if the object is to the left of 2f1, the image is formed to the left of 2f2. If the object is to the right of 2f1, the image is formed to the right of 2f2. So this is the left-left, right-right rule. This is all from me for today's video. Please like it, share it with your friends and subscribe to the channel if you are new to it. So for now, it's goodbye from me. Thanks for watching.